Button. So yeah, welcome to a new day, everybody. Make sure you're signing in for that attendance. Eventually we'll get blind, so it's slightly less bright, or slightly more bright. Well, let's get started. Make sure, like I said last time, that you're going to the assignments tab on the Zybooks website so you can see which part is your assignment. So if I go to, if I go and I click on our first reading assignment, for example, load it. It'll load the first part of that assignment, but there's more than one section I'm assigning. So make sure you can find the rest of them by going to the table of contents, and then that should have this assignments tab open at the bottom here automatically for you. And here are all the things I'm asking you to do for this first assignment. I'm definitely front loading your work so that you have less to do towards the end of the semester. So definitely start early on these assignments, okay? But that's what you're going to do, and you should be able to see the grade that you got so far, and it's going to keep transferring to Canvas as you do more. And here's all the other assignments. This is what I want you to do for that particular assignment. Okay. The due date on Zybooks is wrong. It's always I had to make it the last day of classes so that you could turn things in late. The real due date is always on Canvas. All right. So make sure you know how to see that. One way to do that is to look at this little Canvas calendar thing. Hopefully you found that. Okay. So that's that. So yeah, keep that in mind as you're doing your work. Only the Canvas due dates are right. Okay? So yeah, without any further ado, let's actually have a programming lecture. If you're over there, you'll just have to shout at me or jump up and raise your hand. I'll set that down again later. But yeah, I want to talk about messing up in programming. All right, so let's talk about errors, and we'll go from there. All right. So there's a few different kinds of mistakes you can make when you're writing C++. I took a lot of care to be perfect last time, but maybe you were having issues as you were typing the Hello World program and it was complaining. C++ maybe was complaining at you when you tried to compile it and it wouldn't work. So here are some kinds of errors that are very common that you'll see. All right. The first one is a compile time error, and that maybe one of the most common ones, definitely. That's when you spoke C++ wrong and the compiler had no clue what you meant. And so it didn't even know how to make a program for you. It couldn't even make a program that runs, okay? And so that's like if you said instead of int x42, int x42. The compiler's like, what are you talking about? Int is not a type. I have no clue what you're talking about. So that's the idea, right? That's a compile time error. A runtime error is more fun. That means that you did speak C++ correctly, but the way the program was working as it was running, an error happened that could not be recovered from during runtime, and it was just so bad, and it doesn't know what to do anymore. So that's the compiler couldn't tell that there was going to be an error, or it wasn't smart enough to notice that there was going to be an error, one of the two. Division by 0 with integers, for example, that's undefined, so that causes a runtime error when you try to do it in C++. I think I can give you an example of that. So I'm going to go to my terminal where I give you all my code. I have a folder for lecture 1 today. I want to slowly teach you little terminal commands. So to make a new folder in your current directory, you can say make dir folder name. So I'm going to say make dir lecture 2. And I'm going to go work inside of that today. I'll give that to you later, of course. All right. So I'll make a new file called runtime error.cpp. So remember all your boilerplate, IOStream, namespace standard, main function, return 0. Here is a file with an error that the compiler could never notice, right? Because usually it'll work. So let's say int x equals 42, and let's ask the user to enter a number. All right, give them some room, make space for that number they're going to give us, get it with cin, and then I'm going to see out x divided by n. See where I'm going with that? So obviously, the user could type any number. We should let this compile and run. I'm going to say to compile it, now that I have this file, g++ runtime error.cpp. If I hit enter, it'll make the a.out file. But if I do the -o, I can give it a different name. I'll just call it runtime error to keep things all consistent here. So now I have a file that I can run with the /. So enter number, 2, the program works and runs to completion, right? That's fine. I get 21, that is 42 over 2. If I type 0, though, I get this disgusting message. Floating point exception. That was, I'm not printing that anymore. So that was C++, or the computer itself, the operating system saying, no, error. I'm going to stop the program. Question? You don't have to what? The program file, yes, that should always be .cbp. I have two files right now. I have the actual code and then the compiled code. And this is instead of a.out. I want to give it a normal name now. Okay? Yeah. So we tend to write executable files without an extension. Okay. The last kind of error is called a logic error, and that's the most subtle and it's the worst, and it may be one of the most popular ones too. So a logic error, another word for that is bug. So you've probably heard that before. A bug in the program is when it compiles, it runs to completion, but the output is wrong. The answer that it gives you back is incorrect somehow. So you just got the wrong answer. The program works fine though. Here's a silly example of a logic error. Like here's a simple bug, right? Int x equals 42, and then you make a variable called x plus 1, and inside of that, you put something other than x plus 1, yeah? So obviously all your calculations are going to work. The program's not going to end early with a runtime error, but you're just going to get the wrong answer. That's a bug, okay? I hope that makes enough sense. It's just a fact of life. You're going to mess up as you're programming. I mess up all the time, but we'll figure it all out together. Okay, so before we get into more things that you can understand, I would like to give you one thing that you can't understand. I would like to do something. I'd like to kind of fast forward a little bit and show you something that is kind of where we're going. I'm going to give you a demo of all the stuff we're going to learn like the first half of this semester. Okay? So you don't have to understand any of this right now. What I'm about to type, you will not understand a lot of it. Okay? Just understand that. And I will explain it, though, with my words. And I'm just going to speak C++ fluently to you right now so that you've seen everything once. Okay? Just sit back, pretend like you're a baby, you're learning your first language, something like that. Okay? This is something that one of my teachers did at Fresno State. I took a Latin class, and Dr. Chapman at Fresno State, take a class with her if you can, if she's still teaching at least. She would just like read from our textbook, and we didn't understand it, but like we got a feel for the flow of the language. That's what I'm trying to do right now for you. Okay? So what we're going to do is I'm going to make a counting machine in code. So it's going to model one of these little clicky devices that hopefully you've seen before in like a PE class or something. So you click this little device, it makes the number go up, and then like you can reset the number with this little wheel by turning that. Okay, so what I'm going to do is I'm going to make a new type in C++. Like we have ints and doubles and chars and stuff. I'm going to make a type called counter that encapsulates all of this idea of being a counting device, which is kind of cool. All right, I can make a variable of type counter rather than a variable of type int. And this type is going to hold on to some stuff. It's going to hold on to some data, and it's going to hold on to some operations as well. Okay, which is a weird thing to say, I know. The data inside of the counter is going to be the count that is on the window. So I'm going to store some counts. All right, just one. That'll be an integer. And then some operations that I want to be able to do on this counter are I want to be able to increment it. I want to be able to, before that, I need to be able to like initialize it, like take it out of the box, zero out the count. Initialization, increment it by pressing the button, and then like I want to be able to look at the screen, right? I need a concept of that in code. So like give me back that count so I can look at the screen and see what's on it now after I clicked it a bunch of times. All right, so that's the goal. Again, you don't have to understand any of this. I don't expect you to. This is where we're going, though. Right? So I would like, here's what I want to be able to do, like this. I want to be able to not just make an int x. I want to be able to make like a counter c. That'll be cool, right? And what I want to do with that counter is, well, once it begins its life, got to take it out of the box, initialize it, c.init, looks like that, and then I want to be able to click that button a few times on the window. So like it's 0 now. I want to be able to like ink it a few times. Ink it once, twice, 3 times. So now the count's 3 in theory. And then I want to be able to look at the window, be like c.getCount, give me that count inside of you, view the window, and print out the value you see there to see out. Okay? That's like what I'd like to do. All right? And here's how you do it. to make a new type in C++, you say class counter. Again, don't worry if this is flying straight over your head right now. That's fine. I'm speaking C++ too. So I need everything to be accessible to the user right now. So I'm going to make these operations visible. They're public things. Init is a public thing. And I'll give what I want to do there in a second. And it is a public thing. Inc is a public thing. And get count is a public thing. And then there's one private thing that I don't want the user to have access to. It's secretly. Oh, that's weird. That happened yesterday, actually. Let's see. The best way to fix this will be to turn this off. Sorry, little computer. Force turning off. Yeah, just yell at me when that happens. Sorry. And it forgot that my computer existed, did it? There we go. All right. So, yeah, all these things. These are my operations. They're public things, and then I want to hide the count from the user. But it needs to be there, like the integer count that's on the screen. All right. So there's that. This init here. Here's how I'm using it down at the bottom here. Init is just meant to be called on a line by itself, so it's void. Inc, same deal. And then get count needs to give back something. It needs to give back an integer. It needs to give back the count that is on the screen. All right. And then to initialize my counter, I need to take that little counting piece that's inside of it, that little value, that data, and set it to 0. That's how I take it out of the box and reset everything. All right. And then to inc my counter, I have to take the count and increment it. Whatever it was is one more now. All right. It's one more than what it used to be. And then to give back the current count, I just return that, we say. All right. So that's my counting device. And if I compile and I run this, it's a new file, right, called counter.cpp, 2++ counter, -o counter. Boop. If I run it, it's a very complicated program that prints the number 3. Okay. So this is where we're going in the class. If you understood any of that, great. You didn't have to, but come back here in a few weeks. Like, you'll slowly understand more and more. It'll be useful to gauge where you're at. Okay, so I wanted to show you that, and now we can go back to where we're at. Really? Okay, let's go back and talk about variables. Okay. So, what is a variable? We went a little fast last time, so let's go slower now. So a variable is just a piece of memory. It's a box in memory with a name, right? It's something with a name that could hold on to a value. So like we did this, int x equals 42 before. What that does, when I run that line, I make a box in memory called x, and it's set to 42. If I ever go ask for x, it kind of goes and looks in the box and shows me what's there, right? It gives me back the 42. Every variable has a name, but there is a naming scheme you have to follow. So valid names for variables look like this. They have to start with either underscore or a character, lowercase or uppercase is fine. And then after that, you can tack on digits too. So you can't start your variable names with a number, but you can eventually use numbers, right? And that means you can't have spaces in your variable names. Like you can't have int x space y. That's an invalid variable name. That won't work. Okay, so these are the rules. And so valid variable names kind of look like xy, of course, underscore hello, valid variable name, abc underscore 007, valid variable name. Okay. And people tend to write descriptive variable names, and so you end up writing a lot of words and jamming that into one name. If you can't have spaces, how do you delimit the words? There are two competing schools of thought. Right? Depends on the language, but I'll be using both in this class. So some people like to write long variable names with multiple words like this. This is called camel case, all right? Because the capital letters delimit the new word. They show when the new word starts. It looks like the humps on a camel's back. Then other people just like to use underscores to separate their words. You can do whatever you want, okay? But that's just what people have done before us. Those are some variable names. And yeah, question first? So how does hello and ABC count as a variable name? Say that again, I can't hear you quick. Oh, sorry. How does hello and ABC count as a valid variable name? They follow the rules. That's all. So you could say int underscore hello. That's a variable. Now you can use it. So if it doesn't have if it has spaces variables have to follow these rules. It won't compile otherwise. So if you want to make a variable, you have to say that it exists, and that's called declaring a variable. All right. So to declare a variable, you got to tell me what type it is. And so, for example, when I was using cin before, I didn't have a value yet. I didn't have a value to say like int x equals 42 because I was getting that value from the user. If you want to make space for the variable, though, you at least need to do this: say its type, say its name, semicolon. All right. So that's the goal. It's a declaration, but not an initialization. It doesn't give it a value, but it gives space. All right. It makes space for it. So if you say this, it makes a box of memory holding it that you can reference with the word x now. But like, what's inside now? What do we think? Do we think it's 0? Do we think it's something nice? Any ideas? It would be nice if it was something like that. What could it be? So like question mark. But honestly, the answer is it holds complete garbage. It holds whatever was in memory at the time. C++ is not doing anything fancy. It's saving as much time as it can. It holds nothing at all. It holds like a random value. It could be a different value every time. All right. So definitely make sure your variables have values before you use them. Okay. Holds whatever was in memory. Okay. So definitely make sure to initialize your variables. That's giving them initial values. Okay. So let's see. Let me prove to you, first of all, that is a question mark. I think I have to go to the class server for this because if I did this on my own computer, and I will, I'll give you this code. I'll make a new file called uninitialized variables.cpp. And I'll do this: int x, int y, int z, 3 variables, and I'll print them all out. I don't think that I'm running this on my own computer. I don't think my computer's been turned on long enough to reuse memory. We'll see. And so it might look nice. Oh, no, good, perfect. That's exactly what I wanted. So look, those are the values. Those are the garbage memory values right now that are held in x, y, and z. Cool. And if I rerun the program, they're different garbage memory values. It just so happens that x and z, for a weird quirk of my current CPU architecture / operating system combination, they're the same, but that's not guaranteed. Complete garbage, complete randomness. All right, so definitely make sure you have a good starting value in your variables, because otherwise you're going to get logic errors. Yeah, that's important. So definitely make sure to initialize your variables. Right? Give them values. Give them initial values. So there's a couple ways you can do it. You can declare, wait a little while, and eventually give it a value, x equals 42 later. But you better not have tried to use x anywhere in here, anywhere between. Okay, you can wait, but don't do anything before then. So the first line makes it set to question mark, and then this line, you don't have to say int anymore. Just it exists already. Just talk about the thing that already exists, x. Then it'll be set to, that's a weird looking question mark. Starts out question mark, and then we set it to 42. Okay, so that's what that does. You could do it all in one fell swoop if you have what you want ready. Like that, I'll set it immediately to 42. And then technically, I guess there's a third option if you use cin, because you can say, here's my variable, like take some time to output a prompt, and then I can say cin into x, and that will also set the variable, all right? But these ... better not be trying to use x because it'll be getting that garbage value. It hasn't been set until these lines, okay? Any questions, comments about that? Definitely make sure your variables are initialized. Otherwise, you'll get the wrong answer for sure. Okay. So, where do I want to go next? All right. So this line that sets a value into a variable, I don't like it. All right. It was a bad idea to say equals because honestly, it's more doing the job of what a left arrow would do, I would say. Okay. So, okay. This line, a line with an equal sign, is called an assignment statement. All right, it assigns a value into a variable. It takes whatever this is, whatever b is, could be something very long, computes an answer out of it, and shoves it into a variable called a. Okay, and so what happens after that line is like there's a variable called a. It sets it to whatever b was. Maybe it needs to do some work to get a final answer. If b is like a 2 + 2 or something, it has to make 4 first. But you get the idea. So yeah, if you do x equals 42 and you already have an x variable, now x is holding 42. But the issue is you can come along later and change your variables with assignment statements. The equality, at least in math, is meant to mean like this is its value, it's equal to this, it is never changing, right? That's why I hate this. Because the assignment statement, you can run it again and you can reset the value of x using the equalities, all right? That's sadly not working like math in C++. Variable values can totally change as the program progresses, okay? So yeah, the idea of an assignment statement is the right-hand side of that equals gets run first, gets run to compute a final answer, and then whatever that answer is shoved into the variable whose name is on the left-hand side, okay? That's the idea. So now you understand why this line works, and you can tell me what it does, can't you? Because it's going to run the right-hand side first. So if this is the current value of x is 42, it will compute, right, 43, and then it will shove 43 into that variable. That's one way to increment it, okay? And so everybody was like, I want to do that so often, it's too much typing to say x equals x plus 1 all the time. And so you have some shorthand. You can say x plus equals 1. That's another shorthand for exactly this. Increments a variable by 1. You could also use 2 over here. And then that was still too much typing to people. And so they're like, okay, this is shorthand for increment a value of a variable by 1. So all these 3 lines, this, and this, those are all equivalent. Okay? And now, actually, you know why it's called C++. It was based on a language called C. You get the joke now, hopefully. It's based on a language called C, but it's like one better. Okay? That's the goal. So that's the assignment statement. And yeah, let us continue if we're doing okay. Let me just check my notes, make sure we're on the right track. Oh, one thing I did want to show you. I guess I do want to make a program. I just want to show you what a compiler error looks like. Forgot to do that. So if I do this, call it compile time error.cpp. If I do the int x equals 42, here's what happens. It won't even compile, and it will say int not declared in the scope. Did you mean int? Cool. It's pretty helpful, right? That's pretty nice. And so that's an example of a declaration and an assignment statement if this was an actual int, all right? And it didn't make any executable files because I messed up. All right, back to our regularly scheduled programming. So let us keep on trucking and talk about fancy assignment statements, right? Because it's more than just x equals 42 these days, all right? So let's talk about some new terms as well. So every type, like the int type, think of that cloud again, what goes in there? Those are like, what can ints be? They could be whole numbers, potentially negative, 0, 42, negative 4, and everything in between, of course. So all those values exists for ints, and those are legitimately called values, all right? A value is a basic element of a type. So another word for that is literal. So for ints, like the number 0, the number 42, negative 1, those are all values because they're already something that could go in a variable, okay? All right, C++ doesn't have to do any extra work at all to shove that somewhere, all right? And that is in contrast to something like this, int x equals 2 plus 2. This is not yet an int. It's a larger expression, we say, right? It has to be computed. And then we have an answer, and that's the value, right? We have to compute the value or literal 4, and then that's what's getting shoved into the variable after the work is done. Does that make sense? So like, this is when the work is done. Expression is anything bigger than that. It's some combination of literals and like operations, operators, okay? So I guess technically a value is an expression. It's like it subsumes it, but you get the idea, okay? So yeah, here is the expression, for example, and let's pretend that x was the right value that created 42 when you actually perform the computation to get the value, okay? So those are some new terms. I'll be using those a lot. And I think we're ready for some fancier programs. Are we good? Well, let's do it. I want to teach you some cool stuff. Yeah. The 2 plus 2 is an expression, yes. Because the answer is 4, and it's not yet 4. The computer has to do the work. All right, I want to teach you about division. I have a whole section on division. All right, so division in C++, like I showed you, it's that slash. So I actually have a question for you guys. So go back to the class website, please, and do attendance. Now I'm going to stop attendance the second we're done with this question. All right, but please go to the by clicker page, and I'll start that question. And here's what I want to ask you. What do you think this code prints out? All right, am I tricking you? Try to run it in your head first. If you have time, you can go get it on the class server, but I'll give you a couple minutes. Like, help the people around you, introduce yourself, say hi, see if you can convince your neighbors that your answer is correct. But tell me right now, on the by clicker page, what should this answer be? What's going to happen when I run this code? Are we awake? Eventually, I'm going to have my tutor sit here. So I'm going to want you to sit not for the rest of the day. In the meantime, I can do this. Let me get this thing. I think that was enough time. We're starting to die down here. So let's see what we're thinking. Get that answer in. What are our thoughts? Before we look at it, I'm stopping attendance right now. You're all marked absent if you forgot to get in. All right. So we are thinking B. And that makes a lot of sense, right? 2.5 over 2 is 2.5. Makes so much sense. Let me prove to you what the answer will be. There's only one way to show you beyond the shadow of a doubt, right? So we got int x equals 5. I can just copy and paste this in theory. Famous last words, though. Plus division dash o division. The answer is 2. Huh. 2, not 2.5. So the answer is A. Dun, dun, dun. I'll let you guys talk to each other soon, I promise. If you want to talk, just talk to each other on Discord right now. It confuses me when I hear voices as I'm trying to think. Thank you. All right. So yeah, this is 2, and let's figure out why. Okay, those of you still talking, I need you to stop. Thank you. All right. So let's do a slide on this. This is why there's a whole section today on division. It's called integer division, what we just ran into. Okay. So what just happened was we had an integer divided by an integer, and C++ was like, oh, you want the answer to be an int too, don't you? That's what happened. And what values can ints hold on to? Can they hold on to 2.5? They cannot. Very good. So there's nothing in between 2 and 3 as far as C++ is concerned. It's going to chop off the decimal places. All right. So division works differently on ints than it does on doubles, which are the things with decimal places. All right. There's no room in an int for those 0.5s, and so it just chops them right off. Like if we do 5 over 2, it thinks about 2.5, but it's like, I got no room for the 0.5, so your answer is 2. Doesn't round. Doesn't even round. Okay. So it's a little confusing. That's crazy. Question. Double is a type from last time. It holds numbers with decimal places. Okay. Another question. No roundings. Chopping it off. No rounding ever. Chopping off all the decimals. Good question. Yeah. Which is, yeah, crazy. Weird to think about. So that is unfortunate. So here's the secret. Here's how you get the 2.5 if you wanted the 2.5. Right? We would like to do division on and produce a double, please. That's what we would like. All right. So it depends. Again, it depends on the types involved in the slash. The two things on both sides of the slash, not the thing that you're shoving the answer into. That's also very important. So here's the idea. If you have an int over here and an int over here, the answer will always be an int. That's going to do integer division. If, however, you put one side of that slash, a double, either side is fine, then it's like, oh, okay, you must want a double as the answer. All right? So that will produce a double as the result. All right? That's the goal. So another word for double is called a floating point type. You'll hear that in the book. It's just because it has a decimal place and it's secretly stored in scientific notation. Like the decimal can move around, kind of. That's what it means like by that. But that is a sign. So let me prove to you what's going on here. All right. So let's say this: double res equals x over 2. What is the type of x? An int. What is the type of the literal or value 2? Also an int. What kind of division will this perform? Even though I'm putting the answer into a double, it's still going to perform integer division. So this is going to confuse us as we're starting out. Still doing int div. Dun, dun, dun. All right. So let me prove that to you. The answer is going to be like 2.0. It'll convert it back to a double, but that's still useless to us. So it's still 2. See that? Unfortunate. All right. If we wanted the real 2.5, you got to make one side of that slash a double. All right. It's easier to make the 2 a double because like the double 2 is 2.0. The second you use a decimal place, like C++ sees that it's not an int anymore. Now it's a double. On the right side, x is still an int, of course. Now we're going to get the 2.5. Yeah. So just remember that. That's going to take some time to sink in, I know. What if you had like an x and a y that were both ints and you want to divide them and still get an answer with decimals? You have to convert that int to a double, one of them somehow. All right. There's a way to do it, and it's very ugly. It's called static cast. That's one quick way. So if you have an int and you would like to convert it for a second to be a double, it stays an int really, but just for the sake of for the rest of the expression, this will get replaced with the double version of that int. You say static underscore cast, and then in between angle brackets you put the type you want, so we want double, and then in between parentheses we say which variable we'd like to convert. So this gets replaced with the double version of whatever x was. It's a long-winded thing, but that's the secret. All right. Dun, dun, dun. So let's go to code and let me show that. So let's say I have like int y equals 2, and I'd like to compute 2.5 still, like 5x over y, 5 over 2. Obviously, if I do this, I'm still getting integer division. All right, I'm still getting that 2. So I want to static cast one of these into a double, and that'll make it that side of the equation work out. Static underscore cast into a double of x. Okay? Does that make sense? That's the fun stuff. All right, so that is going. If we just remember that, that'll give me my 2.5, okay? Beautiful. So that's what we want to remember. And then the last thing I want to teach you is about printing doubles. So sometimes you like want to round it to a certain number of decimal places, like you want an amount of precision. There's a way to do that. You have to give some fancy words to cout as you're printing your doubles, and that will control how they get printed. All right. So there's two things that you want to give to cout if you want to control the number of decimal places and the rounding. It's fixed, we're going to say fixed to C++, that, to C out, that is, and that lives in IOStream. And then we're also going to use something called set precision. It's a function. I haven't really told you what that means yet, but we're going to call a function called set precision with how many decimal places we want. And that special function thing lives not in IOStream, it lives in a place called, in a library file called IOmanip, which is short for input-output manipulation. Okay, so I need that if I want set precision. All right, so let me show that to you and how useful it is. So I'm going to include IOmanip, and this is for set precision. All right, so there's that. And here's what I'm going to do with it. Let's print the next double we ever give to cout with exactly 3 decimal places of precision. All right, that's what we're going to do. So here's how you do it. You give both fixed and set precision to cout. They're special variables, essentially, special values that control how cout prints future things. They're not actually going to print anything themselves. So I'm going to say the word fixed to cout. It's not actually going to print anything. It just controls how future things get printed. And I'm going to say set precision and 3 within parentheses there. And that, again, is not going to print anything, but it's going to control how the next double gets printed. And those two together, now if I do like x over 2.0, compute a double, it'll print exactly 2.5, but with 3 decimal places of precision. So I get 2.500. All right, and that would like do a rounding if there was more than that. It's like an infinite decimals, stuff like that. So this will be useful. They have to go together. You'd think that set precision is doing the bulk of the work, but the fixed is also very important. So they just kind of, they're one thing that all goes together. Okay, that controls how things get printed. Question? Yep, that's exactly how that works. If you wanted 4, you'd say 4. That's exactly right. All right. So that concludes my chapter on doubles. Are we good to talk about a different type now? All right. You'd think it would be easy, but no, there's complicated things for one operation in math in C++. All right, let's talk about like characters and letters and words now. Let's talk about characters and strings, char type and string type. Okay. So first of all, let me tell you something cool. If you haven't realized it yet, everything inside of your computer is 1s and 0s, right? So everything, like this entire PowerPoint, is just some giant binary number, essentially. And that means anything that we could store inside of a computer is really just a number. It could be very long, but it is just a number at the end of the day. So that means, specifically, every character we type, for example, everything in the char type is really just a number, right? Your computer, it sees that special number, like cout's like, oh, this is a number, but it's really a character when it gives it to the terminal screen. And then the terminal screen's like, okay, that number corresponds to the capital A character. And that's what I'm going to write to the screen. Okay, so that's the secret. And yeah, your computer just like figures out which picture to draw when it sees the right number, right? That's how it distinguishes between the characters. And back in the 60s, people were like, all right, I would like to store words inside of computers as 1s and 0s. So a bunch of people back in the 60s, they got in a room and they're like, this is the order of the characters. These are the numbers we're going to assign to every character. And that is called, they made a big table and it's called the ASCII table, right? It stands for like American Standard Code for Information Interchange. I don't remember, something like that. But here is the table. If I go to the manual, ASCII, and I scroll down, here's the table. So the capital A character, we're going to look at this decimal column. The capital A character is apparently the number 65. That's what everybody's decided to agree on. They go in order, though. There B is 66, C is 67, etc. And then they take a little break for these special characters, and then the lowercase letters start at 97. 97 is A, 98 is B, 99 is C, and then like space is 20. Space, sorry, is 32. Exclamation point is 33. Like all these characters, they're really just numbers, and those are the numbers associated with them. Okay? And that's going to let us do some weird stuff. All right. So first of all, that means that this is possible. Like when you see out a character, see out is like printed as a character, but we know that every character can be a number, so we can static cast that character to an int because that's fine. And so this will print 65, All right, I hope that makes sense. So let me show that to you. It's very weird to wrap your mind around, but it's just everything's numbers at the end of the day. So let's see out the A character. That's gonna work just fine. But every character is secretly a number, and we can figure out that number by static casting. Static cast into an int, because that's the type I want this time. This thing. Okay? So weird. So cool, though. So chars.cpp. Boop. So yeah, see A and I see 65. They do go in order, though. So B is 66, C is 67. Watch what I could do with that knowledge. I'm going to take... I'll figure this out in a second. I'm going to start with A, and I'm going to add 2 to A. I can do that, right? That will compute ASCII code 67, which is, if I ask it to be displayed as a character, the letter C. Ooh, you're doing math on letters now. That's pretty interesting. At least I think so. All right? Does that make enough sense? It's very weird, I know. Okay, so we also know that we can take a lot of characters and bring them together as strings. Okay? So let's talk about strings for a second now. We know how to make them. You can put them into variables like this with the double quotes now for strings. But every string is made up of a bunch of individual characters. I hope that makes sense, right? And you do have access to each character if you want to. You can get to any of them by doing this kind of syntax, all right? You say S, like the name of your string, then a dot, and then you say at, and in between parentheses you put the index of the string you'd like to go to either retrieve the character there or to set the character there, all right? So it goes to the ith index, and the indices start at 0. So for example, if this was my string called S, it holds hello. In memory, it looks like this, all right? It's each individual character accessible, and these are the indices of each character. Everything starts at 0 in computer science, right? So 0 is the index of the H, 1 is the index of the E, 2 is really the third character. See that? That's the idea. So if I asked for S at 0, C++ would give back to me the H character. And I could use that and just print that single character, or I could modify this if I put this in like an assignment statement, something like that. It's all possible. All right, so let me show that to you. Let's go here. Strings. And remember, if you want to use the string type, you have to include the string library, like that. All right, so I'd like to make a string called S holding the text hello. I guess capital hello is what I had in the slides, right? And Cout knows how to handle strings. It'll print the whole thing. You can also ask, though, for individual characters. So let's get this compiling and running first. Oh, yeah. Really? Oh, I messed something up. Weird. G++. Oh, okay, there's something wrong with this keyboard, sorry. I think it's like, it thinks I'm still pressing the control key. Wow, okay, I broke this keyboard. Sorry. Oh man, I can't use this. I can turn it on again. Huh? Oh, maybe it's the terminal itself. Let's see. If I open a new terminal. Oh no, yeah, it thinks I'm holding in control right now. Okay. If I turn that off. Give me a second, sorry guys. What if I remake everything? Yeah, it thinks I'm holding in a character thing on my computer right now. That's disgusting. If I undo this, what happens? Back to normal. I have no mouse anymore, but okay, yeah. So my keyboard is messed up right now, you guys. I'm so sorry. I think I'm gonna have to restart my computer. That's disgusting. So let's see if I can stop the recording in between.